I'm chairing this session, and our first speaker is Ran Ettinger. Ran, we have just seen him at a tutorial at the teaching committee tutorials last month. He has been in industry quite a while at IBM, if I remember correctly, IBM Research in Israel, and then to Ben-Gurion University. And now he is back in industry with NVIDIA, but he's still teaching. So I'm looking forward to hear about Dafny again, Ran. So please.
Thanks so much, Ligia. Let me share my screen. And so a bit of history for this. I've learned how to do refinement or algorithm refinement from Carol Morgan's book, Programming from Specifications, some 20 years ago as a doctoral student at Oxford. I think it was Geraint Jones and Jeff Sanders who taught me that. And so it was all pen and paper. We were developing some algorithms like in Introduction to Computer Science, the basic things, all the way up to say some algorithms of sorting and using some data structures and proving correctness. So deriving the algorithm from the specification, from the contract, precondition, postcondition, and mostly imperative, iterative programs. So using loops with proving correctness with loop invariants and some recursion eventually, and that's about it. And I started teaching that. It was October 2013 here in Ben-Gurion University in Israel. And the first year was completely pen and paper as I studied it. And then at the end of the first year, I was hinted by Yossi Gil of the Technion here in Israel that, hey, why don't you use Dafny? And I didn't know of Dafny at the time, so I looked at it and I found that much of what I want to say in this course can be expressed in Dafny. And this is what I've done since October 2014, was to teach the same course, the same material, the material from Carol Morgan's book using Dafny. And my paper here really gives a case study from chapter 10 or 12 of Carol Morgan's book of how I speak of chapter 10 is his case study, the first case study in Morgan's book on with a nested loop for insertion sort. And I show in really small steps of refinement in the paper how the refinement laws can be expressed, in my view, in Dafny, and how it's helped me in teaching, for example, in evaluating students' submissions by having Dafny verifying correctness. So I still needed to work hard to read much of the development, but it was a pleasure to see when students were following the refinement steps very, very strictly. It's easy to read and evaluate a program. So I like that part. And it gives the students the feedback that cannot be given by a handed pen and paper exercise. So I really like using Dafny. I'm showing how I do it here in this paper, and let me show some of it here in this little short talk. So I'll try to start. So I've been using this. I've changed since going back to the industry. I've changed the course a little bit, but I'm reporting in this paper about the 2019 iteration of the course. So, and I have, so this is the web page I showed here. Since then, the web pages are no longer open. So this one is open, and it's linked through from the paper. And here I have the material, the exercises, the assignments, and the laws of refinement, some laws of refinement from Carol Morgan's catalog. And I show examples of how to use them. For example, an assignment statement, how it can be written in Dafny and proven correct with a lemma. So if this is the assignment, B becomes N, And this was the precondition, then that was the post-condition. The lemma can express the proof obligation that the precondition for all values of the parameter here, and the precondition indeed implies the post-condition. Which post-condition? The post-condition of the original program, but with the substitution of the left-hand side of the assignment with the right-hand side of the assignment. So it's easy to see the post-condition of the program and then the post-condition of the lemma are very, very closely related, only with B becoming N here. And in the classroom, what I do is I used to open the Visual Studio. I've switched recently to VS Code since version 3.3 of Dafny no longer supports Visual Studio. So I'm now with VS Code, but for this talk, I'd like to show how I've been using this at Visual Studio, and this case study for insertion sort is shown here. I'll go through just a little bit of detail to express how to show how the refinement can be expressed here in Dafny. But just before that, I'll say that as I've heard that Dafny could be used, and I've started adapting Dafny, I could see it was really interesting to see that Carl Morgan himself has been teaching with Dafny. It was back at the end of 2014. And I've seen that, and he's written and he's spoken to this, the previous iteration of this workshop about, for example, he had this paper and course on informal methods, how he's been teaching, some with Dafny, some with the whiteboard, how to develop algorithms and derive the algorithms from the specification, prove correctness, be able to prove correctness, be it partly or fully, and he's been teaching this, I believe, to the end of first year or beginning second year students, and he's justifying this really nicely, why it's best to catch them when they have some experience, they suffered they experienced some mistakes, bugs, errors, and it's not too late. What I'm trying to say here in this work is that for my experience, having taught this material strictly with Carl Morgan's refinement laws, that it's possible also to get those students later in the curriculum. It's great to have them early if you can, but I've been proposing this as an elective course. So to final year students, they can be third year in Israel. The computer science program is done within 3 years, or there is a software engineering program here at Ben-Gurion University for 4 years. So the students come from either of these programs for their final year. So they are coming with some experience, but they don't know anything about, they don't speak so much during the first 3 years of proving correctness of verification, except for those coming from the software engineering program, where they do have in parallel on their final year a mandatory course on software verification, teaching model checking and other things. So they know something about it, but not too much. And so I'm presenting them with the idea of refinement. We start with they know about contracts, so I show them, okay, if here I'm showing now like the 10th, 11th, and 12th lectures of a semester of, we have 13 weeks. 2 lectures a week for 2 hours each. So all in all, 52 hours for the full course. And I really go by Carl Morgan's book. So really taking his examples, not all, I mean, I believe, like chapter maybe 15 or so. So I don't get to the data refinement during this course. So it's only algorithm refinement. And I really go week by week, I go with the book. So starting with, say, factorial and square root. So loops, getting to learn different techniques of of phrasing the loop invariance in a way that can help you into proving correctness. So I spent 3 sessions, 3 2-hour sessions on insertion sort. So they've come to this point where they already know about loop invariance. They know some of the, they know how to prove correctness of the post condition after a loop and after an assignment, and make sequential composition of the program into 2 parts. The first, for example, to make the loop invariant hold in the beginning, and the second will be the loop itself. And so they know a little bit about developing loops. And here's a case study. We spent 3 sessions because the first session, let me open this here. The first session is only for the outer loop of insertion sort. So we start, the first session is about the contract first. So what is the contract for any sorting algorithm? Could be specified this way, that we want, that we take an array here of integers. In this case, it doesn't have to be integers, but okay. We take also, for convenience, a ghost parameter that is the multiset, the bag of elements in the array, just so that we can express simply in the post condition that the outcome of the array is a permutation of the original code. So it's the multiset in Dafny it said. The multiset of the sequence of elements in the array is the same as it was in the beginning. And that's ensures that's a post condition. And we ensure that the array is sorted. Okay, what is sorted? We put it here. I show them how if we forgot about this post condition, as Carol Morgan is saying in his chapter 10, I believe, the specification wouldn't be good enough, strong enough, because then we could just assign the same value to all elements in the array, and it will be sorted. It's not a permutation of the original. So it's important to speak about the contract, but then each exercise, when they do assignments, starts off with a given contract. Here's a contract. You go ahead and derive the algorithm and provide the come up with the loop invariance and prove correctness. So what can I show here in the next few minutes that will be interesting? I'd like to show, for example, at the end of the second session, we have, at the end of the first session, we have a specification for we have the outer loop and the specification for the insertion. And then the insertion itself, where is it? Sorry. And then the insertion itself. So the insertion itself, we know that the invariant for the outer loop holds. We know that we entered the outer loop, so the index is not at the end of the array, and we need just one more element sorted, just I+1 elements sorted, and we go into an inner loop. And here, at the end of the second session, I wasn't fully deriving the program with refinement laws. I was skipping some steps, and my guard for the loop was really not efficient, like in Carol Morgan's chapter. The guard said that, where is it? It's here, it must be here. The guard said that, that there exists an element left of the current index that is bigger. So you need to continue working, but that's really not efficient to have a quantifier in the guard. So what we do is at the very end of the third session, let me show the program for the third session. I believe it's number 12, lecture 12, yeah. So at the end of the finals, at the last session, we really replaced the guard of the inner loop with an efficient one. So we end up with the actual code, the executable code. And we don't have to go back and change our development, because, and then I showed them how we can justify that we can argue that the new guard, the efficient one, and the original guard with the existential quantifier, they are equivalent. They're not always equivalent, but they are equivalent whenever the invariant of the inner loop holds. So we phrase this as a lemma. Where is it? Lemma equivalence, equivalent guards. We say, okay, whenever the inner invariant holds, it's true that the efficient guard is equivalent to the original guard from the first two sessions. And the nice thing about that is that we don't have to go back and do the refinement steps again. So we end up with executable code, efficient code, and fully verified. In the paper, I don't speak about how to prove the lemmas, but I do spend time about that, and we spend some time of the course learning how to write proofs in Dafny, be it with some calculations, and I will end with that, showing the full version. Where is it? It's this one, I believe. The complete version. And here, so here, for example, there are proofs that Dafny just accepted as is. So we were lucky there, but we still learn how to write the proofs, for example, with calculations, sometimes with recursion or induction, just recursive lemmas, so that we can prove correctness of lemmas, but we also learn how to stop at some point and say, okay, this thing is clearly correct. We can argue to the human reader why it's correct, but it's harder for us to prove all the way to Dafny fully that it's correct. So we'll leave it as verify false, it's called in Dafny. So I teach them not to fight with eventually the theorem prover, because we don't learn how the theorem prover works at all, but we learn how to write the refinement laws, to obey to follow the laws and the proof obligations in a way that will eventually end up convincing Dafny as well. Most of the time fully, and some of the time just with hints to the saying, okay, this lemma, the user should, or me, the evaluator of their assignments, should prove that it's correct, not Dafny itself. So I've been teaching this now for 8 years. The last 2 years was, as I said, a little different. I adapted a little bit Ada and Spark at the end, but mostly Dafny now with Dafny 3. And it's really great fun. The students are able to really prove correctness of not the hardest of algorithms, but for example, inserting an element into the heap, or finding, searching a search tree, or stuff like that. So I love it. Some of the students like it, as said earlier, love and hate. Some less so. Some are confused with the syntax and with things. But I have 52 hours, so it works well. I think it works really well. So thanks for your attention. I'm ready for a couple of questions, maybe.
Thank you, Ran. Great topic and nice timing. Are there questions? Claudio? You are muted. Yeah. Okay.
So thank you for the nice talk. I mean, my question is about the feedback of your students, especially by linking, you say, I mean, I was starting doing this by pen. Now I'm using Dafny, which automatized most of the stuff you were doing manually before. So what's next? What do you expect the evolution of this to be?
Well, so I was having this in the paper, this table saying, okay, so in this iteration of the course, I had what was it? It was up to 3 members of each submission groups, and you could see here for one assignment, the heap insert, I believe it was 8 fully verified, but they worked hard. I think they were happy with their with the result. I was happy with all of them having fully verified programs, and you had those, for example, interestingly, 6 groups that that were willing to go with my hint that they don't need to prove everything, and they argued convincingly for the correctness. But you had some students that really didn't argue correctly, or they had logically incorrect lemmas. And it doesn't mean that there was a bug in the program, but it means that maybe the invariant was not strong enough. And some of those students will be really frustrated, saying that, well, there are bugs in Dafny. It's all about bugs in Dafny, or stuff like that. So I'm not always successful in really making them fluent in coming up with phrasing the proof obligations correctly. So I'm not sure there's really a need to, I stopped, this year I stopped using the actual refinement laws, but instead doing it a bit more informally, but still in Dafny. So I don't know what the future is for this, but I'm trying different ways of doing it really strictly or doing a bit less formally. Yeah, some students are frustrated, some are really providing great results that I think, I don't know if they're happy about it, but at least I'm happy with their results.
Ran, there is a question in the chat from Ina Scheffer. I don't know if you see it. I can read it for you. She's asking, would you say that from your experience in industry that teaching students correctness by construction will pay off in industry? Like say better code quality, even though some of the students will never use a program verifier ever in their lives again?
Right. Great question. No, I cannot say yet. I'm quite new to NVIDIA formal verification effort for C programs. Like a year ago, I've joined them. So it's too early for me to say. I'm just saying what I say to my students is really the course is not about Dafny. Dafny is just a tool to help me evaluate your assignments and to help you get some feedback. But we learn, the reason we learn how to come up with the proof obligations is that we aim to be able to use pen and paper in different languages without formal, completely verified proofs, but just to affect the way of thinking about the programs. I feel that for me, it really transformed me. About my students, it's been 8 years, but I cannot say yet. No, I cannot say yet.
You know how they say the best way to learn something is to teach it. So
Exactly.
yeah. All right. We have to move on. Thank you very much, Ran.